All right, good morning, everybody. So I went ahead and sent out a talking points message this morning and last night about free food. It's been nice to seeing some of y'all early in the morning. I think I've delivered food to about 20 different families, and so some of y'all are valiant enough to come out and say hi to me. Nonetheless, it's all G. I understand not all of you need the food, but it's always nice to have, some snacks. And, eating the school food does take you back, when you're in the cafeteria and then, you end up throwing up all the food because it's disgusting, or you don't have enough ketchup for your pancakes, right? So, anywho, we're going to get started with today's lesson. Let me change the music. All right, so Metallica. So today we're going to be analyzing data like a pro, not a noob. Okay? So we're going to be looking at speed versus step length. And we're going to be analyzing bivariate data. That just means, bi means two. Variate means like variable, right? Two variables. So we're just looking at data that has two variables. A researcher found an association between a dog's stride length and its speed. So stride length is like, when the little homie is walking. I can't draw a dog. That's my dog. When it walks, the stride length is how much it walks when it moves its legs, okay? So they're saying that the longer the dog steps, the faster it goes. The predicted speed in meters per second, okay? So this is the speed as a function of step length in meters. L is given by this equation, okay? So this L represents the length of the stride. So, what does the rate of change of the function tell you about the association between stride length and speed? So, remember, the slope here is going to be speed over length. And since it's 4, right, the slope is 4, this means the 4 represents 4, miles per hour, or it's meters per second. 4 meters per second. So every time, per 1 meter, right? Every time the dog stride, am I saying that right? Yeah. Every time the dog's stride length increases by 1 meter, his speed is increasing by 4 meters per second. Wait, seriously? That's it? Wow. Well, what else does it tell you? It's increasing, right? Because the slope is positive. Is this a linear or non-linear? It's linear. Yep, that's about it. So is there an association between the weight of an animal's body and the weight of an animal's brain? So now we have an animal. Let's suppose we have a human. This is Bob. Okay? Or Tom, whatever you want to call the person. And so depending on how much they weigh, does that also mean that their brain is going to be bigger? Or will it be smaller? Or is it static? Meaning it doesn't change. So we're not just looking at Bob, we're looking at all these aminals. What does a cow go? Moo. What about a gray wolf? Ow. What about a goat? Bah. A donkey? Hee-haw, something like that, right? A horse? Nay. What about a potar monkey? I don't know. What about a cat? Meow. What about a giraffe? Yep, I don't know either. What about a gorilla? Ooh. What about a human? Bet. What about a rhesus monkey? Ooh, rhesus monkey. Y'all should do some research on rhesus monkeys. Kangaroo. I don't know. Oh, it's a good song. What about a sheep? Wait, does it make the same sound as a goat? Bah. I don't know. What about a jaguar? Or a chimpanzee? Anyways, what am I doing? Okay, so we want to see if there's an association. Oh, hell no, I'm not about to graph all of these. Bro. Yes, we are. Okay, body weight and brain weight. Body weight, X, Y. So 465, 423. 465. 36, 120. 36. 36, 120. 28, 115. 28, 115. Donkey. 187, 419. 187, 419. 521, 655. 521. Wait, I forgot the second number. 521, 655. 655. 521, 5. Wait, what? Yes. Ride the crazy train. 10, 115. Bam, bam. Something like that. A cut. 326. Heh, small brain. $529, $680. $529. Something like that. Gorilla, 207, 406. A human, 62. God damn, our brain. 62, 1320. We're gonna ride the crazy train. 7, 179. 56. Wait, what? 35, 56. 56, 175. 100, 157. 52, 440. 192, 180. All right, so looking at this data, right, just by looking at it right now, just, obviously I'm not the best person to be doing this, but like, what does it make you think of? Like, would you say there is an association? Do you think the more you weigh, the bigger your brain is? Or do you think there is no association? So after removing the outliers, so let's identify the outliers, if there are any. Do you see any outliers here? Because I do. I see the human. And then really, if you wanted to push yourself, these two also, to some extent, right? Now, just looking at the data here, would you say there appears to be an association? So I'm gonna let you write that, okay? So I want you to write, there is either an association or no association between body weight and brain weight. I'm not going to tell you what I think personally. I want you to start, sort of like answering this on your own. Do you think there is an association or there is no association? Let me change the radio station. I don't like this song. Whatever. Using a piece of pasta and a straight edge, fit a line to your scatter plot and estimated slope. What does the slope in the context of the brain and body weight mean? So if you had to draw a line, I'm going to say it looks something like this. Actually, let me use a... something like that. And I'm going to say it goes through this point right here. And it goes through this point here, okay? So if we were to find a slope, the rise is 200 grams. The run is, let's see, it goes from 50 to 250, so that's 200 pounds. So it makes me think that the slope is 1 gram per pound. So what does this mean? What does it mean? It means for every pound of weight, your brain grows or weighs more by 1 gram. And obviously you have a starting value, whatever the heck that is. Does a fitted line help you identify more outliers? So do you notice any more outliers, or is it kind of just like, Yeah, I don't think there's any more outliers, in my personal opinion. Nah. By the way, I think I already said this in a different video. That's the chemical name for salt. You'll learn it in 10th grade. So use one of the... Oh, see, you can't collect this data because we're not in class. I mean, we are in class, but it's like kind of weird. By the way, y'all, after spring break, because of this whole extension, I'm gonna be actually, well, obviously I'm gonna be assigning work from the workbook, but at the same time, I'm gonna be pushing y'all to be doing a lot of the heavy lifting in terms of working. I might start having class sessions on Zoom because we still have, unfortunately, let me cross this out. We still have 2 units to cover, right, online, but one of those units is quadratics and inequalities. And I really wish we were in class for this because a lot of people struggle here, but I think it'll be fine. I don't know. Please let me know what y'all think about these videos. Like, if they're not as effective, like, let me know. Don't just like sit there and be okay with it. Oh my god, this song is on hit. Okay, so you can't do this one. We don't have the data. Seriously? So let's just look at the summary, okay? People often collect data in 2 variables to investigate possible associations between 2 numerical variables and use the connections that they find to predict more values of the variables. Data analysis usually follows these steps. You collect data, you organize and represent the data, right, on a graph, and you look for an association. So once you graph the points, then you tell yourself, is there a pattern? And if there is, what does that mean? You identify any outliers, right? So obviously you will have outliers. That's normal for everything. And then you find a function or like an equation that represents that association. So maybe just maybe for our exam, because we technically, do I have to give you an exam? A lot of you are like, no, no, no. Someone like you, I wish nothing but the best. Okay. I was thinking maybe like I can have y'all do some sort of like data analysis, like maybe with your friends, or maybe just having you go out. But some of y'all don't have backyards. Because I was thinking like maybe you could like, I don't know, take a handful of grass and then measure the length of the grass. What does that even, what are you even trying to find? No, I don't know, but I'll think of something, because I think it'd be really cool for y'all to legitimately become like little scientists and like actually start gathering data and like do some analysis. That's the whole part of like mathematics. Like we learn it to be able to model the world. I mean, look at this pandemic or epidemic of like the coronavirus. A lot of people were thinking, oh, it's growing linearly because only 10 people are being affected every day, but that's a lie. It's actually doing this. And right now, we're like right here. We still haven't seen this craziness up here. But anywho, okay, yeah. Anywho, I'll think of something. Go ahead and do the homework. I'm only doing the classwork. I'm pushing y'all to go ahead and try to the homework. If there's something you honestly can't do because of data collection, or it requires like you to communicate with other students in the class, just cross it out. But I'm still expecting y'all to be doing the practice problems for these lessons, okay? And if you haven't been doing those for the other ones, now you got some work for spring break.